Hi everyone, I'm Elaine Wu from C Studio, Edge AI Marketing and Partnership. I'm so happy to join Eurovision 2022, this special event to discuss about bridging AI from the digital to physical, aka Edge AI and real-world practice. For this topic, I also learned from Andrew and Stanford webinar, Bridging AI's proof of concept to production gap, where he demonstrated machine learning projects encounter significant bottlenecks and challenges on their road towards practical deployment. I'm also happy to share when implement Edge AI, what challenges we have met and we have seen, and also some practice how we're dealing with them. I'm also looking forward to all the session or the following session from the leading companies, speaker, and also the communities. So AI is quite widely adopted in the internet and the software industry we're living with. For example, the email, advertisement, and also the social media. But however, when we want to implement the AI in the real world applications like in the smart cities and manufacturing, healthcare, the medical, we will meet a lot of challenges in perspective from the training and to the deployment. So for example, there is not always enough good quality data waiting for us, and also we want to have a good performance at the edge in a very constrained devices. And also for the hardware and the manufacturers, they will meet the problem whether the board, the hardware, their manufacturer is have the good flexibility. And also, for the end deployment, we need to consider about how we're gonna maintain the whole life cycle. And also imagine if you're gonna implement the AI in a very constrained environment. For example, there's no network or no power supply. How are we gonna do that? So we think no matter you're a solution provider or you're working on the software platform to offering the tools to help the developers to working on their own AI product. I think there is several things we need to consider about. So first is the tools or the solutions should be helping the developers, enterprise developers to faster to market. So whether we can have the fewer data sets to foster the training, or for the model or the application can be scalable and remotely deployment. And also for the hardware perspective, it should be adapted to the practical, no matter how is the network and how is the power supply or the other constraint environment. And it should be tailored to the needs. The hardware itself should be customizable and also can also meet the requirement for the POC and also the testing. And also sustainability is quite important because we think working with an innovative community and also working with some software tools provide the unified pipeline from the training and to the deployment. That is very promising to help you to ease the whole R&D development and also the life cycle. So let's see where the Edge AI is happening from our use case and the examples. So the Korean company called Interflow AI, they're producing a Edge AI platform that is deploying the computer vision at the livestock farm, can manage 20,000 pigs or the cattle 24 hours per day. It measures real-time data of the livestock, for example, the animals, the eating habits, or the how much weight they've gained, or they're detecting if they have the disease to help the farmers to better understand their livestock and the farm. And also, the sales group platform is also taking the computer vision to electron microscope, because for the electron microscope and some of the lab instruments, they are generally deployed in a network constrained environment. So bringing the edge computational resources to the microscope is very necessary. And also in Hong Kong, the Armitage, a solution company, they are also deploying a petrol robot as an underground parking lot. This petrol robot is equipped with Nvidia Jetson Xavier NX, also our computer, to detecting the license plate, and also it can enable the emergency alert for fire and also the smoke, and also equipped with the people counting. We have also seen the many examples, like in the Industry 4.0 at the construction, like the helmet detection ensure the workplace safety. This example that is produced by Lab, a very good AI solution company, and it deployed with the ULV5. And also the retail and the QSR, the quick service restaurant, to minimize the wait time of the customers expect to the quickly order and receive their foods at the quick service that is produced by Always AI, and also some community project by our friend Restaurant Manawer, and is using the JSON Nano to enable the multi-stream object detection using the ULV5 Nano, and also the traffic management to ease the congestion and the fuel consumption and the air pollutions. So you can also check out his GitHub repo to find out how to get started this tutorial. So in recent years, we are seeing more and more discussing on edge computing's benefits and also edge AI. So we clearly see the benefits from the edge computing, bringing more efficient processing right directly the edge and near the sensor, where the data is happening and collecting. And also it can leverage the AIoT, the sensors for the multimodal processing, and compare with the traditional computing, where the data directly transmit to the data center or the cloud. Edge computing brings much more low latency and security. And what is more important is about the privacy. No matter you're placing the audio, voice, or the computer vision at the edge, the privacy and the security is always the prioritize the consideration from our customer and the community end. So, and also when you bring the AI to the production, so resilience and remotely the management and scalability is also the top considerations. So when we implement Edge AI, we are also seeing the specific changes from the enterprise developers end. So when they design an application as a POC stage, from the training to deployment is always involves many manual steps. So they want to show the project timelines. And also, when they move into the deployment parts, so they want to place this whole device with no moving parts, but also can be extendable. So for example, if they want to change the network, or if they want to extend more the camera to enable the multi-streams. And also, the device should be 24/7 reliable operation. And they also want to maximize the performance with a better inference rate at the edge. The Seed Edge AI platform provides devices and carrier boards and peripherals and software tools and AI solutions, working with our ecosystem partners and also the communities. So we're targeting on the helping the both developers and the enterprises to deploy their applications across the different industries. So we are NVIDIA's preferred partner and also the Raspberry Pi design partner. So we're bringing the different form factors, the hardwares, and also for example, like the Nvidia Jetson or the Raspberry Pi, the CM4, and also where at our website you can also find the core or the other devices. So in 2022, we bring the two kinds of the devices of the reservoir and the recomputer, powered by the Nvidia Jetson. So the reservoir brings more heart rate high-speed connectivity, and more local storage. For a computer that is much smaller, and the form factor is nearly the same as the Nvidia official dev kit, but it comes with the Nvidia production grade module. That is the whole product line with the Jetson Nano, Xavier NX, Ornament NX, and also this week last week's the Nvidia GTC released the Ornament Nano. So I see that we're also offering the agile manufacturing from 0.1 to infinity, which means you can buy the device or the boards directly from seed, or you can come to us for looking for the customization from the small batch to the large batch. And we are also offering the pre-configure and the software customization and one-stop the go-to-market fulfillment, resale, and the global distributions. So we're also calling the ISVs and the system integrators to working with us to integrate your unique AI techniques to resell or the co-branding the license, the devices at our channels and deliver the solution together. We're always happy to working with communities to co-inventing the next generation the hardware together with our with Seed platform. So for the first problem, faster to market, we're working on this tutorial after fewer data sets and the faster training to based on the transfer learning along with Ultralytics, ULV5, and the RoboFlow. We use the RoboFlow to annotate the data sets and also use the Ultralytics Hub to train the model. So we have published the step-by-step guide on our wiki. The result is pretty good for the single object. You just take the 2 hours with the 500 images and get a map 0.5 about the 95 percentage, and also you can get just 1 hour to train fewer like the 200 images, get a 88 percentage at the map at 5. Yeah, so as this guide, we also provided some examples like the road signs or the smoke, the wildfire, the wildfire detection. Yeah, so and also for the data sets, you can also use the data sets that such as the Coco data sets, or we will recommend you can explore at the RoboFlow universe because they provide the data sets like the 90,000 data sets with the 60 million images available as their RoboFlow universe. For the deployment, you want to always want to get a better inference at the edge. So we also have a guide to using the Tensority and the DeepStream for the Nvidia Jetson. So and also 100% kudos to the Wang Xinyu and also the DeepStream, the Yulu. They provide the very good guides to how to use these tools. So we also combine them together on our wiki and test it on the Nvidia Jetson Nano, Xavier NX, and even the AJAX Orin. So for the NX with the int 8 on the ULV5 small model at the 640 and 640, the frame per second is already around the 60, pretty well, right? And so on the Ajax Orin, that is much more better. You can achieve a frame per second around the 100 and also 140. That is pretty cool. And so for the Nano, actually you can also get the good frame per second. This is the output that's by the Raspberry Manova or our good friends at the community. So using the DeepStream SDK, it can achieve the 16 frame per second on the S model and the 30 64 per second as the Nano model. So even though the Nano is the entry level of the Nvidia Jetson, but if you are choosing a low resolution images, or you can also choose the Nano model or the S model, you can also achieve a a result that is workable for the AI for the edge AI applications. No code or low code platform is always a good way to help beginners to enter into AI and also create their own customized AI applications. So we also have this open source no code vision AI tool that is built up with Node and also Docker. So for the beginners, they can quite easily to as easy as using only 3 nodes to developer to deploy a AI applications using the ULV5 and the RoboFlow at the Nvidia Jetson. So at our repo, we also have many examples. For example, this is also showing how you can just use the 3 nodes to enable a grocery store item management. For bringing an AI solution in perspective of the software, I would think short the project timeline faster to market is quite important for developers working at enterprise to choose the right tools or the resources. And also, we think have a pre-built system for edge AI integration will faster this process. It doesn't mean we're going to pre-configure everything to make the every application to have a out-of-box experience, but try to pre-configure as many as possible will ease this process. So in the training and model parts, I think Nvidia NGC and also the some edge inference server provides the good containers, and also the OpenMM Lab they have the good wide selection from their model zoo, as well as Always AI also provide over 130 plus the different pre-trained and ready-to-use model. And for if you want to optimize the model, besides we mentioned you can leverage the Tensority, but Daisy also offers the very promising the optimized model for you to get ready to deploy it. And also from the experience within click and deploy to try to lower the barrier for the users or even the beginners is always a good way to scale the AI applications. And also when you want to bring your application to the production, it is quite important to include secure OTA updates, fleet management, and remotely update models. So, and also for the software parts, it is quite important to have the various Python API to help you to integrate it into current systems like your the Azure IoT, AWS, or the other PaaS platform. And also it can enable the real-time analytics like BI or the data lakes. After we have done model training and validation, we are going to deploy it. We can directly deploy as a server, PC, or the cloud, but considering the power consumption and also working as a real use case for the different scenarios, a compact size the embedded system boards that is more fit for the different use case, such as the Nvidia Jetson or the Raspberry Pi or the Core. For the Raspberry Pi, you can also using another accelerator like the Core USB accelerator to run at the edge. Nvidia just released RTX 40 that is insanely powerful. But for the single GPU or the distributed multi-nodes GPUs, that is good for the AI training and data center streaming, simulation, and the 3D games. And also another question. So we're bringing the AI the happening on the smaller and the smaller size, but can it be smaller like a just a thumb size the hardware. Yes, it's possible. Like for that is called the tiny ML. Or you can use our wheel terminal, a ARM Cortex M4 based microcontroller connected with plug and play our groove sensors such as motion or all the onboard the gesture sensors, environment sensors to train a model working for microcontroller at the edge impulse. With edge impulse, you can very easily to build up your own custom model in just 5 minutes. And you can also see there is some example like artificial nose to detecting bread or coffee, or build up a lightweight AI-powered serial camera for self-camping or the handwriting recognition. Jetson Orin Nano is also just released during the last week GTC. So we can tell the Orin Nano actually that brings up to the 80 times AI performance than the Nvidia Jetson Nano. It brings the 40-inch 8 tops powered by Ampere GPU, and also it comes with up to 8 GB memory rather than the 4 GB memory that is limits in the Jetson Nano. And also, Orin Nano and Orin NX series is 100 pin and form factor compatible. So we're also working on the carrier board and the full system based on the Orin series. So hopefully we're going to release very soon this year. So we're also looking forward to all kinds of the suggestions. If you are looking forward, we can bring that and make it happen at our hardware. Besides, we mentioned Tensority is a must-have to help you boost the inference at the edge. In the hardware perspective, the key benefits of the Nvidia Jetson is that it combines a CPU and a GPU into a single module and processing in a small and low power package. So DLA, Deep Learning Accelerator, is a application-specific integrated circuit that is capable of the efficiency performing the fixed operations. DLA's throughput is typically lower than the GPU. It is power efficient and allows you to offload deep learning workloads and freeing the GPU for other tasks. And the Tensority is responsible for generating the DLA engines. DLA is available as a series of the AGX, NX, and Orange series. DLA just offer more the top AI performance and its native fusion of the convolution bias and also the max pooling. In perspective of the hardware, brings a low cost and customizable embedded hardware that is friendly to a embedded system designer. So for the edge AI applications, it requires the power efficiency at the edge. For example, the Orin Nano from the 5 to 15 watts. And also for the carrier board, it requires a rich set of the IOs like CSI, USB, PCIe, I2C, and GPIO to meet the different requirements. And also moving from the testing to the pilot to the scalable solutions. It also requires, it is also better to pre-configure some environment or the edge inference server or the other containers to make it more ready for development and deployment. And also to meet the different requirement across the industry application, like from the robotics, smart city, retail, agriculture. So SEED have the product line of the Nvidia Jetson from the different form factor of the carrier boards to the LiDAR sensors, the 2D, the RP LiDAR, and also the cameras like TOF, depth, door, and the single cameras, and also the accessories like the heatsink and also the enclosures. I also want to share about what is the IoT into the wild or Edge AI into the wild. That is quite different with the Edge AI applications we're familiar with, like the video analytics in smart city or the smart transportations. So we're taking our new SenseCap sensor to the deep forest for detecting the wildlife, like the panda in the Sichuan province. Because we had a discussion with local government, they told us this kind of sensor, like the 24/7 operate or the whole year, keep operating the sensor is quite necessary to let them deter the poachers or let them to better understand and know the wildlife activities. So what it make it happen? We use the LoRa, that is the abbreviation of the long range, which means it can transmit the data to the miles away the gateway and also keep working on the ultra low power down to 2 milliwatts at 1 frame per second. And also, it comes with the industrial grade enclosure, which means you can just keep that working for years on the very harsh environment. With our SenseCap Mate app, you can just few clicks to deploy, to display and manage the data via our SenseCap map. So we are also looking forward to seeing more wild scenarios is leveraging AI and computer vision or the AIoT technologies to solving the real world more harsh environment problems. So in a summary, bridging AI from digital to physical, there are several considerations from the software and hardware end, and also the practical environmental end. So for the software, it is quite good to choose a low-code platform for the developers design their applications working with a unified pipeline, and also that is very friendly to the hobbyist to learn the AI. And also, when you design your software system, that is important to think about if the application can be scalable and remotely for the deployment and also the fleet management. For the hardware parts, you need to consider about whether the device can adapt it to the practical environments. It requires to have a small form factor supercomputer, and also for the Nvidia Jetson we tested using Tensority and the DeepStream, you can achieve a great frame per second at the edge. You can also choose the Raspberry Pi or the other form factor SBCs, such as the Cora, or using the Raspberry Pi with the accelerator. And also for the hardware design, it is good to offering the cost-effective with the general required I/O sets, but it can be differentiated with the customizable service. And what is more important, to grow up with a open source community and speeding up with the amazing platform and the developer tools will be great to help you to substance your AI, the product, and also ease the whole pipeline for the whole R&D process. Thank you everyone for joining me today. We are also looking forward to working with more open source projects, software platform system integrators, and also community developers to join us co-create next AI hardware products and also integrate your unique AI techniques to our current embedded system to emerging like the different solutions across industries. So if you have any questions, so you can find us at Twitter and LinkedIn, and also just email us at edgeai@c.cc. Thank you.